Hey, this is 6-Volt in Von Doom's lab. This video is going to be a tutorial on lead hook strip. So I know Rod did a tutorial on how to build it, so this is kind of going over the other stuff. So actually on the next slide, it kind of goes over the 4 things I'll be going over. The first is the RGB LED controllers that, are working with lead hook strip and kind of what I recommended, what could work, and kind of what things will work in the future. Then a high-level overview, how everything works. Then group file programming, and the last is game default file programming. Okay, so let's go into RGB LED controllers. So right now, currently, it's 24-bit RGB controllers, which is just RGB, right? 8 bits for each one. So 8 bits times 3 is 24. And it's ordered green, red, and blue. And this is kind of a normal kind of ordering. So if you go to a lot of addressable LED strips, they're ordered this way. So you got to make sure it's ordered this way. If not, then you can change it in the code, but then you have to change it and recompile. But pretty much this is what is working currently right now. Then the next thing is the protocol using it's a single pin, so it's one pin, non-return to zero protocol at 800 kilohertz. So I'll go talk a little more about that too. And also right now what we're more worried about is the number of controllers, not the number of RGB LEDs. Because some controllers will control 3 RGB LEDs. So you can have 300 RGB LEDs and 100 controllers. So you actually put 100 into Hook of the Reaper. You don't put 300. It's more because that's what the lead strip hook is talking to the controllers, not to the LEDs themselves. So that's what it's more worried about. Because right now with them, it's one LED, one RGB LED per controller. But in the future, I'll put support in for 32-bit, which is red, green, and blue, and white. So this kind of always is in. I could just recompile the code and put that in. But right now it's only using red, green, and blue. It just kind of skips the white. But to put the coding in for white LED for power reduction is pretty easy. So I can put that code in. So if you do want to use RGBW in the future to lower the power, you could. So when I release the full version and the open source code, I'll have all that in. But right now, it's still in pre-production. And as I announced, pre-production code is closed. Then once it's all done, it will be open source to everybody. But right now, the firmware itself is open source to everyone. So everybody can use it. Doesn't cost anything. So as I talked about the single pin non-return to zero protocol at 800 hertz, I did kind of draw out some kind of picture of it. So since it's single pin, it's just a data pin. So there's no clock with it. It's kind of like USB. So how does the clock work? Well, it's a clock aligner is what we kind of call. For like USB 2, it kind of sends some clock edges down before it starts sending data. Then it kind of trains to those edges. So if you look at like 1 and 0, at the beginning of the period, it always has a rising edge. And that's what the clock aligns to. And the clock is 800 kilohertz with a period of 1.25 microseconds. So you can see the period here is 1.25. So what they did with this is they broke it up into 3 parts. So the first part, both data 1 and 0 is high. The last part, both 1 and 0 is low. So the data is actually in the middle part, the middle third part. And as you can see, if it's 1, it's longer. If it's 0, it's shorter. So how does that latch in or flop in the data? So actually that does it on the falling edge. So it clock aligns with the rising edge, then you latch in the data with the following. And if you kind of follow that up, it's kind of right in the middle of the 1 and 0. So that's kind of how you send data. But how does it know when the data ends? Well, you just keep it at 0. Since you're always going to have this rising edge, it knows data is coming through. Then, the first one will know how much data is going out and how long it will take to reach to it. So that kind of waits until all the controllers get the data. Then once it goes low for the data sheets are a little weird on it. Some of them say 50 to 200 microseconds, which is like 40 to 160 clocks. So as long as that stays low for like 50 to 200 microseconds, then it shows the data up onto the LEDs. So that's kind of how the protocol works. That's how a non-zero kind of thing. So when you read, like, if you're wondering if the LED controller would work, it's kind of what you're kind of looking for, this protocol. So I just kind of want to put this up there so people know what to look for. So the next slide is kind of what I recommend for RGB controllers right now. And that's going to be the WS2812B, WS2812B Eco, and WS2813. So the WS2812B Eco has some power savings, and looking at kind of the power, it seems like it cuts the current in half for white. So when you do white, you have 20 milliamps for each red, green, and blue. So you have 60 milliamps. But on Echo, it seems like it cuts it in half, and you have 30. So that reduces the power for half. So all these controllers use 5 volts, and they're red, green, and blue, so they don't have the W, and ordered in green, red, and blue. But you got to check with that before you buy it to make sure. Since it's 5 volts, you're only going to have one RGB LED per controller. And kind of the reason for that is you need about 4 volts per RGB LED. So if you have 5 volts, you only can do one. So then what you normally see a lot is 12 volts. Well, okay, 12 volts divided by 4 is 3. And you see you have 3 RGB LEDs per controller when you use 12 volts. And the next one is 24, of course, that's 6 RGB LEDs per controller. And you kind of want to use that, because if not, you're going to be wasting a lot of power if you don't. So if you use 5, it's kind of the closest, since they don't sell like 4 volt power supplies. 5 volt is a lot more made, so that's kind of why they went. And for the WS2812B and the WS2813, the max power for RGB LED is 0.3 watts per LED, and this is when it's using white. So this is when all 3 LEDs are on. You get 0.3 watts. And the max current per RGB LED is 60 milliamps, and this is for the WS2812B and the WS2813. So easy way to do that, you can go 5 volts, because to get power, it's volts times amps. So you go 5 volts times 0.06, and then that's where you get the 0.3 watts, or 300 milliwatts. So what extra does the WS2813 have versus the 12? Well, it has extra data in. So if an LED fails, it will keep on going, and so it doesn't block. So if you had 100 LEDs and the 50th LED goes out, then 51 through 100 won't work because it's not getting the data. But since you have this extra data line, that 50th LED won't work, but 51 and on will work. So everything will work except for that 50th LED. So that's kind of the one thing with extra on the 13 one. But I think a lot of people, if you had a blown out LED, I think a lot of people will fix it because if you're flashing and all that, it will be really noticeable if you had a LED out. So that's why I think it might not be too much worth it, because I think people will just fix it because you can just solder in a new LED pretty fast. But that's kind of the one advantages the 13 has. So these kind of the ones I recommend kind of right now. They're kind of like one RGB LED per controller, and actually the controller is actually in the package. It's mounted into the LED package. So there is some other ones that will work, but are not recommended. So there's the WS2811. And this has actually two modes. It has the normal mode at 400 kilohertz and it has a fast mode at 800 kilohertz. So you have to make sure it works at 800 kilohertz if you have it. Like I said, if these are not recommended, I'd probably only use it if you have it. And if you have it, you kind of make sure then. The 11s came in two flavors, one with 12 volts, which usually had 3 RGB LEDs per controller, or it also came in at 5 volts, where usually it's 1 RGB LED per controller. And then instead of 20 milliamps, the constant current per LED was 16.5 milliamps. So a little lower power. And this is, I should say, this is all with 50/50 RGB LEDs. Well, what is 50/50 LEDs? That's 5.0 millimeters times 5.0 millimeters package. So that kind of gives you the X and Y of 5 millimeters. And that's how big the LED packages is. And there's different ones out there. There's 2020, so that's 2 millimeters by 2 millimeters, so it's smaller. So since it's smaller, it uses less current and less power. But kind of all these are using 50/50. There's a lot of different ones out there, and they kind of sell them with different ones. But these are kind of more with all 50/50s. Also on here, I forgot to put in WS2812, just 12. And I think that is 12 volts too. But because it's 12 volts, it usually has 3 RGB LEDs. And that's kind of why it's not recommended. But the B is the 5 volts and all that. Then the other one is there's a WS2815 out there. And this runs at 12 volts. So this is good for 1 to 3 RGB LEDs per controller. So the best case is to have 12, since it's 12 volts, is to use 3 RGB LEDs per controller. So it's good for that, and it's good for long run. Since you have higher voltage, you can have a kind of lower current demands kind of for it. But the one problem is if you use this 12 volts with 1 RGB LED per controller, it's not efficient, right? Because like we said, if it's 60 milliamps, you, instead of going 5 times 60 milliamps to get to 0.3 watts, you're going 12 times 60 milliamps. And that will give you 0.72 watts. So you're having a lot more wasted energy, and this turns into more heat. So if you're doing 1 RGB LED per controller and you want that, it would be better to do the WS2812B than 12B Echo or the 13. Then that will all be like 0.3 watts per LED, which is a lot better than 0.72, which is almost 2.5 times the wattage, and you're not getting that anything out of it more. You're still getting, if you just use 1 RGB LED per controller. So you're using a lot more energy and getting nothing back except for a lot of heat. So that's kind of going through my recommendations about the controllers, and if you want to use a different one, you can look around since there's so many out there, and and also you have to calculate the power and all that. But that kind of ends the going through the controllers for this. So the next one is high level overview. So this is kind of a high-level overview of how everything works with Hook of the Reaper and the emulator and the lead hook strip and the strips and everything. So this picture I kind of drew two out. So at the top you'll see like an emulator, then the debug port goes into demolish shooter, which then goes in the Hook of the Reaper. Then this is a virtual serial port, which is USB, and this is kind of the line of the computer, right? I have computer up here. Then you have a USB cord, which hooks into lead hook strip, which is a Pico 2 or Pico 2W. And then you have these lines going to the controller, the single pin protocol going to the controllers. Then, you can have like a whole bunch of, you can have like a 50, 100, 20, whatever, how many controllers you want in these. So then this one has 4. So this is kind of, if you're using demolish shooter, this is kind of like the emulator is here, then demolish shooter will kind of read the memory and output the output signals to Hook of the Reaper. Then Hook of the Reaper will read the output signals and then tell lead hook strip what to do. Then that gets to the strips, kind of. That's kind of the flow it goes through. Then this one is kind of without demolish shooter. So you just have the emulator. I have debug here with a Lua script. Just, if like MAME does have some Lua script ones. So I put that in. So you have the emulator. So you have the output signals going to Hook of the Reaper here, which then goes to a virtual serial port, which is a USB. So this is where it's leaving the computer. Then you have a USB cord to lead hook strip, which is a Pico 2 or Pico 2W. Then I just have 2 strips here because I didn't want to draw all 4 out. So sorry, I was lazy. But I just have 2 strips here, like I said, with a whole bunch of controllers in the strip. So this here, right here, is to represent the controllers kind of in the strip. But I kind of down here, I kind of draw a line. This is latency. So as you can see, going through all this stuff, it makes a lot of latency, right? The emulator, then reading the memory, then getting the Hook of the Reaper, then doing the USB, then to the microcontroller, then microcontroller to the strips. So that's why I did a ton of work to make lead hook strip work really fast. I try to make the latency really, really low and really, really reactive with it. So to make it look as it goes, and also you can program everything. So that was kind of this to show how much it goes through and why latency can be a problem going through all this. So the next picture is kind of more focused into Hook of the Reaper, right? So you have your output signals here, which is kind of like recoil, ammo, damage, and life, right? I kind of have some examples of here. So kind of how it works with Hook of the Reaper, you have some code here called the hook TCP socket, right? And this is what gets the output signals with the TCP socket. So when a game starts, it will tell hook TCP socket. Then that will tell the hook light engine and the hooker engine, hey, a game started, and that will tell the load. So then now it knows what game is starting. It will look for the game file or the ROM file. And if it doesn't find the ROM file, it looks for a default file. And if it finds one of those, it loads up. If it doesn't find any, then it doesn't do anything. And then it's the same thing kind of with the hooker engine, right? You have the default LG game files down here, and you have the game and the default file too. So then once it starts loading up all the data, that's where it kind of gets the output signals. So this game file, the default file, will tell, hey, I need player 1 recoil, player 2 recoil. It will kind of list out all the output signals that it needs. So then it will create a list of all the output signals that it needs. Then it will send that list back to hook TCP socket. And also this also goes to the light controller too, because once it's loading up the game or default file, it has the commands in it too. So then it loads up all the commands. It preloads all the commands before, when the game is loading up. So before when the game is loading up, it reads the file and loads all the commands up. So if you're using like a random flash for the recoil, so player 1 random flash will be random flash struck 0, and it will load up all the info like time on, time off, how many LEDs to flash, what color, all that will be sent to the lead hook strip. Then the next thing, like damage, that would just be a flash, right? So then that would be flash struck 0. So player 1 damage will be flash struck 0, and it will load all that info in it. So once everything gets loaded up, the attract pattern stops, and then it kind of just goes black. Then the lead hook strip is in game mode and ready to start getting commands to do the flashing and all that, all the display stuff. And that's kind of happened in load. So when it reads that, it kind of preloads all the stuff onto it. And that's how I try to keep latency low, because I try to preload everything on it. So when I do need to when a recoil comes in, so I look for the 0 to 1 transition. So from right here, so if that comes in to the hook TCP socket, it will know, hey, this is looking for player 1 recoil, and this might be looking for player 1 recoil. So then it would send that data into the processor, right? Then the processor says, okay, I need to do the random flash struck 0. That's player 1 stuff. So then it would tell the light controller to say, do random flash struck 0. So then that sends it out to the virtual serial port on the USB. Then that sends it to the lead hook strip, which then will do the random flash on the strip, whatever, if it was like the first or second strip or whatever. That's kind of how like the process goes through then. Like damage, like I said, that was flash struck 0. That's kind of works the same way. Then if it was player 2, it might be flash struck 1. So then that kind of gets processed here, then gets sent up here, then gets sent out. But that's kind of more zooming in to Hook of the Reaper to see kind of how it works, how it loads up the commands with the file, then how it processes the output signals too. Then that talks to the light controller, which then goes out to the virtual serial port into the device. That's kind of the whole process of everything. So hopefully now people have a kind of good high-level understanding how all this works. Okay, so next one is we're going to go to group file programming. So group file programming is pretty easy. Since the groups are just the strips, right? So the first strip is 0, or group 0. It's strip 0, group 0. Groups and strips are kind of interchangeable on this. So if I say strip or group, it means pretty much the same thing. Second strip is 1, third strip is 2, fourth strip is 3. So it kind of starts count at 0. So you have 0, 1, 2, 3. Then you can have 256 colors, and you can have 256 color maps. And color maps with one color is allowed because display range with one step can just have one color. So that's why color maps, because usually on Ultimark stuff, color maps needs 2 colors or more. But for light hook strip, color maps can have 1 or more colors. So okay, so now let's kind of go to the web page for lead hook strip group. So this is the main page, right? I'll make sure. So the good thing is you just come to here to light controllers. Then you see group files here. Then you can go lead hook strip group file info. So then that'll give you info. It says lead hook strip is right now on Pico 2 and Pico 2W. and kind of goes through some of the information I talked about. So this is like the first strip is 0, 1, 2, 3, and example of how to use it in the game file. And it kind of just talks about that, like how group and strip are kind of the same thing. Yeah, please note that group and strip are interchangeable in this group file throughout the LED hook strip documentation. Then it talks about colors. So colors, you can see down here, like it's, so colors have red, green, and blue, then it's 8-bit. So 8-bit is 0 through 255. So 2 raised to 8 is 256, but since we start at 0, 0 through 255 is the 256 numbers. So that's why like color red is 25500, right? Because it's red, green, and blue. So then green is 0, 255, then blue, then you have yellow, then white, white's all everything. Then color map down here, you can have color maps are just a list of colors. So you have like color map, bullet blood is red, white, white, white kind of thing. So it has 4 colors. So that's kind of why it's called a color map. So a group file for LED hook strip is just pretty much this stuff. It's just colors and color maps. So then I have another example down here where you have more like display range players kind of thing. Then I have purple, cyan too in there. Then also I give examples of like illegal things that can happen. So if you make like a color map with no name, or if you go over like 255, right? I have 375 here. So that will kind of air out. And that's kind of some of the things. So the color map, the group file is pretty easy. It's just colors and color maps that you'll be using with the game and default file programming. So any color you're going to use, you got to make here. Then color maps that you want to use with the display range, you got to put in there. That's pretty much all the stuff you got to put in. Okay. So, and another good thing for the group file is power control with the color intensity. So this is if you don't have enough power to drive everything. So like usually, well, in this one I show like the worst case is white. That's like 255, 255, 255. And if you add all those together, you get 765 kind of envelope. And then I talk about power usage. So you never want to use 100%. So if your LEDs added all up together are going to use like 30 watts, you don't want to buy like a 30 watt power supply, right? You want to go 30 watts divided by 0.8. Or if you have a power supply already, you could go wattage times 0.8. You only want to use up to 80% of the power supply. You never want to go to the max. And there's a couple reasons for that because, you know, voltage does fluctuate, ground kind of sometimes fluctuates. So you want that guard band there. You want that 20% guard band. So you're not pulling everything to trip things. Okay, so let's say now your max usage is 30 watts, but your power envelope is 20 watts. So that's 2/3, right? So now we have, like up here, like I said, we had 765 envelope. So what we can do is you go 2/3 times 765, which would give us 510. So okay, we can use up to 510, right? And these only go up to 255. So if we want to do white, we only can go 170, 170, 170, right? Which is 510 divided by 3. So we can take some from this and put it towards here. If you don't, you know, this is perfectly balanced for white. If you wanted more red, you can take from blue and put it onto red, right? As long as you don't go over the 510, it should be all right. So since it's 2/3, you like, two colors is fine. You can go 255, 255, right? Because that will only get you up to 20 watts, right? Because 255 plus 255 is 510, which is 20 watts, right? Then one color, of course, will be 255, which will be 10 watts, right? Okay, so now let's do it a little less. Let's say we still have the 30 watts, but we only have 10 watts, so 1/3. So we kind of do the same thing. You go 1/3 times 765, and that gives us 255 as our power envelope. So if we want to do three colors balanced white, we go 85, 85, 85, and that will give us 255. So like I said, you can take from this to add to this, or take from that to add to that, or as long as you don't go over 255. Then two colors, right? You have 127, 128. You add those together, you get 255. Then one color is 255. So that's how you can kind of limit your power usage with color intensity. And it's kind of a good way to do it is, like I said, just, say, okay, max is 765. That's 30 watts. But if you don't have 30 watts, you go 20 divided by 30, which is 2/3, and you times that by 765. Or 10 divided by 30 is 1/3, and you do that. And depending on how much power you have, and that's how you can cut down. Because you don't have to cut down like all the numbers, right? In this case, you only had to cut down the three colors. The two colors and one color is fine. Then in this case, you had to cut down three colors and two colors, but one color is fine, right? So that's how you can do power control with color intensity with it. And that's kind of the one other major component of the group file if you don't have enough wattage to drive the LEDs. Okay, so now let's move on to the last one, which is game default file programming. So there's three things you needed to program, right? It's kind of like the default LG. You have three things. You have the output signal, which can be, which with the light display you can invert it. So the way you invert it, you put a tilde at the end of the name. So here I got player 1 CTM recoil with the tilde at the end. So then that inverts the data if you wanted to invert the data of the output signal. Or you have no tilde and it's just a normal value. So that's kind of the first thing. The second is light controllers and groups and strips, right? So that's I use that as a pound. So the light controller can be seen if you go into edit light controller window. So if I'm here and you go edit light controller number, right here I have 0. So that's, I have lead hook strip. So this is light controller 0. So it starts at 0, and if I add another one, it will be 1, then 2 and 3. So this is where you can see your light controller number is right here. Then with the groups and strips too, like I said, you have 0, 1, 2, 3. Or if you only have 2 strips, then it's going to be 0 and 1. Then the last is the command. So it needs to match up with the light controller, as there is Altimark and lead hook strips have different commands. So if you have you're using lead hook strip, you need the lead hook strip commands. So those kind of the three things that you're kind of looking for. So now let's look at the game default file and lead hook strip command file. So coming back here, so from the home page, you hit light controller. Then you come down here, you have game default file info. Then down here also you have lead hook strip commands. So let's go into game default file info first. So this is kind of what I kind of talk about, how you need like output signals, controller and groups, strips, and commands. Then there's 6 rules you kind of have to follow when you create it. So the first rule is the game default file must start with an output signal. So with the colon. Then from the output signal, it can go to another output signal or to a light controller in groups. It cannot go to a command. So you can't go output signal to a command, but you can go to the other two. Then from light controller in groups, it can go to another light controller in groups or to a command. It cannot go to an output signal. So light controller in groups cannot, next thing cannot be an output signal. Then from a command, it can go to an output signal or light controller in groups. It cannot go to another command. So you can't have command, then another command. Then the game default file must end with an output signal or a command. It cannot end in a light controller and group. Then the next one, I kind of updated the same light controller and groups cannot be used twice on the same output signal unless it's one of them is background or display range command. And I'll kind of go more into that later. That's kind of at the bottom. So these are kind of the 6 simple rules you kind of have to follow. So going from output signal to light controller and groups and commands, and kind of gives you the rules to see going from one to the next kind of thing. So I kind of give out a lot of info in here, but we can just go down here. So this is kind of when I started explaining, like an output signal is this, right? So the line must start with a colon. So if it doesn't start, if it's the second space starts with a colon, Hook of the Reaper loading stuff is not going to see it. The line has to start with a colon. Then it will know is an output signal. Then as I talk about it here, you can invert the value of that output signal by putting a tilde into it. Then how the output controller in groups work, it starts with an exclamation point. So exclamation point 0 means light controller 0, the first light controller. As I said, it starts at 0, 1, 2, 3, 4. Then you have your groups or strips after that. And you can have multiple of those. And also you can have an output signal and also have multiple, if you have multiple output or multiple light controllers, you can have those all in a line too. So if you want recoil for multiple controllers to do something for like player 1 CTM, you can put all these 3 lines under it. But each light controller must have its own line. So you can see here, this is 0 with its groups. That's 1 with its groups, and this is 4 with its groups. But a bad thing to do is you can do this. You can go controller 0 with group 1, then you go controller 0 with group 2, and controller 0 with 3. You should not do this. This is like I have it here. This is highly discouraged. It's very non-efficient. So what it does, it creates different commands all the time. And then it has to chunk through 1, 2, and 3. And it'd take a lot longer to go through it. If you just go controller 0, then group strips 1, 2, and 3, it will work a lot better. So do not, when you're doing the controller, make sure you have your strips and groups all in one line. Don't make them into multiple lines because it will make it a lot less efficient. So that's one thing you don't want to do. So now we got the output signals, we got controller and groups. The last one is commands. So down here is some examples. So this is an ultramark command. This is, since it has the LED strip in it, this is the LED hook strip command in there. So as you can see here, we have player 1 damage, and let's say controller 0 and 1 are Altermark devices, right? Light controller 0 and 1 are Altermark. So this is light controller 0, group 0, light controller 1, group 2. Then it will flash RGB. You know, like time on is 50 milliseconds, time off is 40 milliseconds, and we'll flash it one time. So that would do it. Also, what you can have, you can also load up, instead of changing the output signal, you can do this too, where controller 2 and 3 are lead hook strips. So you have controller 2, so strip 0, then controller 3 with strip 1, you can do the flash strip. So 150 milliseconds on, 100 milliseconds off. You flash it one time with the color red, and this is the weight. So if you did have Ultramark and lead hook all into one, you can do it this way. Or if you want to, you can separate them. So this is just these two separated. So you have 0, 0, 1, 2. So you have 0, 0, 1, 2 with the flash, right? So this is just separated 2. So you can do that too. You can separate the output signals too and have them done 2 times. So this is like a little efficient during the load, but when you're playing a game, it's the same efficiency. So you don't have to worry about that. So when you're playing the game, it's the same efficiency. It's a little better to have it this way when loading it up. It's a little faster. But that kind of just shows you how you program it. And this is for lead hook strip. This is kind of an example, right? So if you don't have an Ultramark, you can just look at this. So player 1 damage, right? Controller 2, 3, strip 0 on 2, strip 1 on controller 3, right? Do the flash. And that's how you kind of program it. You have the output signal, the controller and strips, and the command that you want to do. And that's kind of what you do with it. Okay, so this is kind of getting into that rule 6. So the same light controller and groups. As you can see here, this is controller 0, group 0, then controller 0, group 1. So it's different. So you can have different commands for that. So that's fine. But down here, as you can see, P1 damage, you got group 0 is 0, 0 is 0 with the same. So this would air out because it would do the flash, then it will try to do the sequence, but since it's doing the flash already, it wouldn't do the sequence because it's already busy. This group of pins or strips is already busy with the flash. So so this is just wasted, and that's why it will air out. The only time that you can do it is if one of them is display range or background. And I'll put this in, it's not in yet, so if you try this, it will air out in version 1.3.2 of Hook of the Reaper. So in version 1.3.3, it will be fixed. So if you want to like display life, right, with display range, and also have the death flash, which is off life, but that wouldn't work in 1.3.2 because it will say, hey, this is controller 0, strip 0, and the same thing. But since display range is kind of a background thing where you can have stuff run on top of it, it's fine. This should be able to work. And like I said, it's just a bug that will kind of get working. So that kind of explains how you do the commands, right? So you go, right, output signal, right, controller and strips, then command is a kind of example of how you do that. And also I give examples of how it works too. So if you actually go into Hook of the Reaper, then you go into light files, right? There's example of House of the Dead, lead hook, right? And if I open that up, right, it's kind of you can see the commands, right? You have output signal, right? Controller strip command, right? Then output signal, controller strip command kind of thing. And that kind of goes all down. So this kind of example of a lead hook strip. And this is with 4 strips kind of thing. Then here I can show you a 2 strip. This is just with 2 strips, right? So you have 0, 0, right? Then 0, 1. So you got player 1 and player 2. Okay, so that's kind of, how you can set up the output signals, controller groups, and commands. So now what we want to do is look at lead hook strip commands, because these commands are different from the Ultramark commands. So we come in here. So up here I have cut and paste save commands. So these commands you can cut and paste anywhere. These commands are not cut and paste safe, and it gives the reason why. Like reload and death has a player number on it. So I'll tell you where that player number is that needs to be changed. And display range has a max range in it too. Then here, this kind of explains right now, I haven't had any problems with this, but each random flash, and sequential have 30 structs per each. So flash has 30 structs, random flash has 30 structs, and sequential has 30 structs. As I was kind of telling you when we do the high level thing, like random flash with recoil, that would create random flash struct 0. Then the other one would be random flash struct 1. So long as you don't use all 30 up. And also for each strip. So here I have damage and I have flash, but I'm using all 4 strips. So this will create 4 flash structs. So each strip is different. So this will, when it loads it up to the lead hook strip, it'll say, flash struct 0 is on strip 0. Then flash struct 1 is on strip 1. Then flash struct 2 is on strip 2, and so on. So that's why it kind of creates 4 structs out of that. Right now, I haven't had anybody reach maximum. It can easily make it bigger, but of course, when you make it bigger, it takes more memory. So I'm trying to keep the memory kind of low. But that's kind of one thing. I haven't had anybody run into any problems with that. But if people make the default really big, you can run into this problem. Okay. So now these are the flash commands. So you have the normal flash, and I have all the arguments here. So you have time on, time off, number of flashes, color, and weight. So what's weight? Well, I found out when you're doing like random flash for recoil, it's hard to get like damage flash or death flash up, because the random flash is kind of eating it all up, right? If the random flash is going, it would ignore the regular flash. So the weight is kind of a buffer. So if weight is a 1, if it can't run, it gets put into a buffer. So then when the command stops on that strip, then the flash will go in right away. So it kind of just buffers the command. And all flash, as you can see, have the weight with it, because I saw the flash was having trouble getting in, especially when you use recoil with random flash. So then you have a reload flash, and this kind of has to be tied to the ammo. And because it's being tied to the ammo, it needs to know the player number, right? Because each player will have different ammo value. So that's why it needs to know the player number. Then you have the death flash, which gets tied to life, and Of course, each player has their own life value, so you need to put the player number. So that's why reload and death are not cut and paste, kind of safe. So then you can see all the arguments here. Then if you go to the bottom here, you have arguments, and it'll detail all the data for the arguments and know what you put into it. So the next one is random flash. So since you're not lighting up the whole strip, you're only lighting up a number of LEDs. So you go from 1 to 10 LEDs you can light up. Then you have time on, time off, number of flashes, color. Then also, just like the Ultimark, you can enable a second color, which has a probability tied to it. So what I kind of did with the Ultimark, you can have it white, 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 then red, like you hit somebody. So it's white, 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 then red, like you hit somebody. Then that's what you can do here. The first color can be white, the second color can be red. Then you can enable the second color with a probability. So it can be, then it goes from 1/2 to 1/12. So that's 50%, then 1/12 is 8.3%. So that's a big range, 50 to 8.3% chance that it will do the second color. So then I give examples how to do random flash without the second color, then random flash with the second color. So if you put the 0 here, then you don't need to put the probability in the second color in. If you put 0 here, if you put 1 in, then you need that there. Then the next one is sequence command. So I have the normal sequence, which is time delay, the number of LEDs it lights up per delay, and color. So that's a pretty easy one to do. It only has like 3 arguments. Then it has reload sequence, which is good for ammo when you reload. So you have time delay, number of LEDs per delay, color, then player number, because it's using the ammo, it needs the player number. So that kind of gets added on to it. Then, so those are kind of like the 3 kind of basic commands. So the next big one is display range. And this is kind of where it shows your ammo or life, or you can put any value that you want up on it. So the first thing is you put your max range in, which you need right now. So for like House of the Dead 4, I know it's 30, so that's why I put 30 in. Then the number of steps is the number of colors. So if you saw my video where it has 3 different colors as it goes down. So that's why you need the color map. So the first color in the color map is the bottom. Then the next color in the color map is the next one up. Then it keeps on going up. But what if you have like 4 steps and only 3 colors? Well, then it goes back to the bottom. So it goes from bottom, next one to the top. Then it goes back to the bottom and goes through the sequence. So if you have more steps than the color map, it goes around. Then if you have a color map with only 1 color, it just uses that 1 color, and it's kind of a waste to do. So time off is because commands can run on top of this display range. So time off is kind of like a buffer. It goes black for that time. So you can put in like 100 milliseconds. So it will show the display range, then it will be black for 100 milliseconds, then I will run the other command. So then I talked about the color map. Then the last one is enabling sequence reload. So a good thing is if you're doing with life or ammo, you can have it automatically do a sequential reload. So if you, as you can see down here, you can just put a 0 on that, then you don't have to put the other parameters in. But if you do put a 1 in, you got to put the time delay and the number of LEDs per delay in there. So that will enable sequential reload. So if you do have ammo and you reload, then it does that green kind of building going all the way up kind of thing. So those are kind of the 4 commands, and like I said, all the arguments down here detailing what they can be. So that's the commands and all that. So that's all the info to how to program it. So these two files are used to program the game and the default file. So this is, I kind of drew it out to show if you do invert the data of the, so if you do the output signal data inversion, so you've put the tilde on the end, kind of what will happen. So I kind of showed you here recoil, and you care about when it goes 0 to 1, right? So this is when it runs the command, right? When it goes 0 to 1. So it runs it there, 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 there. If you invert the data, it kind of delays it, because most time recoil is on is like 5 to 20 milliseconds. So then it'll just delay it 5 to 20 milliseconds. So instead of happening here, it will happen here. So now it happens when it goes back up. So this is where it goes from 0 to 1, right? So that's where it will do the display command now if you invert it. So if you want to do to delay the recoil flash a little bit, you can do the inverse of the data, and it'll delay it a little bit. The one thing, inversion data doesn't work good on multi-value things, because if it's like 3, so if it's 1 or more, it's just going to be 0. Then when it's 0, it's going to be 1. Then if it's like I said, 1 or more, it's just going to be 0. So you can see here, like, right, if it goes from 3 to 2, you have a recoil, recoil, recoil. Then right, when you go 0 to 30, you have a reload, then recoil, recoil. But when you invert it, you just have a reload. When you go to 0, it goes to 1. Then it goes from 1 to 0, so then it looks like you have a recoil. So you only have these two events at 0, kind of. When you go into 0, then when you go out of 0, you only have these two things. So inverting like ammo or life is not that useful, but it could be useful for other things. But I just wanted to give a graphical display of inverting the data and what it does. Okay, so a lot of people go, hey, okay, now I can start writing out the game and default files. But I say, well, before you do that, a good thing to do is to go to the test light control window and learn the basic display commands, which is flash, random flash, and sequential. Then once you kind of learn those with the arguments, right, a good thing to do is to come up here to bring up like the website. Then you can go here to LED hook strip, right, and you can have like flash. And you can bring up Hook of the Reaper, then come down here, then you go to Test Light Controller, right? So here's, I have 0, right? I can put 0 here, which is the first strip, and you have flash. So you can see here I have flash, but I don't have reload and death flash. That's because it's just a special flash, right? Reload looks at ammo, and then when the new ammo value is bigger than the old one, it says, hey, a reload happens, and it does the command. Then death is a little different. I look at life, but I have an algorithm to look at it, because to make sure when you close it, because when you close a game, your life goes to 0, but I want to make sure it doesn't go, because when you go to that, also you have main stop too. I don't want the command, the death flash, to happen if you exit the game. So I have like an algorithm to try to stop it most of the time. But that's why you just have flash, right? Then, as you can see here, like other things you can't go into, right? It shuts a lot of the things off. So you can see you have time on, time off, number of flashes, color, then wait. So of course you can't have wait, since you're only running one command. You can't see wait happening. So wait is not in the test light controller. So if you want to do it, you put your time on in, you put your time off, number of flashes, then the color gets all loaded. So your color is all here. So then you can select it. So once you have it, like you can put like 200, 200, then 1, then I have the color, then I can just run the command. Then that will run the flash, right? Then random flash is a little different, right? You go to random flash. And as you can see now, you have second color. You can enable it. So to enable it, you hit like that. Then your probability is here. So 2 is 1/2, so that's 50%. Then 12 is 1/12, which is 8.3. Then you have 1/3, 1/4, 1/5, all the way to 1/12. So that's your probability, right? Then this is your second color too. It has all your colors in here. So that's if you want to do random flash with, also down here is the LEDs you want to flash. So you have 1 to 10. So then you can put like 5 in. So it's a little weird because it's down here, but all the stuff is here and that one's down here. But then you can run the command. Then if you don't want to use the second color, you just turn that off, then you can run it. But like I said, this is more to learn about the arguments of the commands. Then the last basic one is sequence. So sequence is time delay, the number of LEDs per delay, right, in color. So here's the time delay, so you can put like 500. You can pick the color. Then this one's a little different. This is LED flash here, but this is the one you want, LEDs per delay. Then that's 1, 2, 4, 8. And that's, so if you have 1, it turns 1 on, delay, turns another one on, delay, turns 1 on. If you do 2, it turns 2 on, then delays, turns 2 on, and so forth. So then you can run the command with that, and that's just a sequence command, which not too many in. So once you go through those are the basics. Then you can get to kind of the big boy, which is display range. So as you come down here, your color map for it is here, so you can pick that. Time DR, time display range, that's, you know, when it's going from display range to a next command. So this is the time where it blacks out. So if you put 100, so it's 100 milliseconds, it will black out. So you'll see the ammo, then it'll go 100 milliseconds, it'll black, then it'll run the command on top of it. Then this is if you enable the delay. So if you look here, you have enable sequential reload. You have time delay up here. So the time delay, or time display range reload is the time delay over here. So you have time off, which is time DR. Then time delay is time DR reload, right? Then you can put like 500 in that. So then you can go number of steps, which is 3. Like House of the Dead, like I said, was 30. Then you can enable sequential reload. Then LEDs per delay is 1. Then you can, when you run the command, you'll see these will come up to lit up now, but nothing will happen on the strip. And the reason for that is you got to update the display range. So this is where you update the display range number. So if you type in 30 and you update the display range, now the strip will light up fully, right? If you type in 15 and update it, now half of it will be displayed. Then if you go to 0, then nothing will be on. Then since, like I said, I preload everything, you can't run a command on top of it. So that's one thing you can't do. So then if you want to end it, you just close display range. So that will stop it. So then if you want to run it again, you have to run command. So then you can not enable sequential reload and run it to see what happens if you want to. But you probably want to do that, and that will get you really versed in all the arguments of all and how to do everything with all the commands. And it's a really good thing to do, Because, you know, if you don't know the arguments, what they do, and what their values is, it's kind of, programming it is a lot harder to do. So definitely, and also it's good to use to get all your settings on, right? Time off, time on, time off for flashes and all that. It's good to do it here because if not, you got to play a game to look at it. Where you can just look at it, you can just put the values in and just run it right away here. So. Okay. So that it should only take like 5 to 10 minutes, like I said, but you'll learn a lot. You learn all the commands, you learn all the arguments and everything. So definitely don't skip this set. Just go to the test window and learn how to do everything. Like I said, just have the commands in the background with Hook of the Reaper in. Okay, so I do have future plans for display range. Because right now you have to put the max count in. Then it calculates everything when you're doing the setup, right? But I was thinking and did some calculations, and I think there's enough bandwidth where I can do the calculations on the fly, kind of like I do with Hook of the Reaper, where when you do a reload, like, you know, when you do a reload, if that, you know, so like a House of the Dead, you do a reload, you go to 30, and you keep on going, it will always be 30. So then it would be already be kind of calculated and you'd be kind of be done. You don't need to do anything. But other games might have different values. I know House of the Dead, Scarlet Dawn has different guns, right? So when you reload, it will take the reloaded value as the max count, but it will have to calculate everything out during it. And also, I have to make it work with the old way too. So here's like a command. Here's the old way without it. So this is what I'm planning to do for the future. I'm going to have a command where you can put 0, 1, 2, and 3 in. So if it's 0, which is defaults to, it's not enable the auto count, the auto calculations when it does the reload. So then, but then you have the other one. So if it's a 1, it does the auto count enabled for values up to 100. Then 2 would be 1,000 and 10,000. And this is more because it eats up memory, right? If you do 10,000, it eats up, I think, 20 kilobytes per strip. So if you do it all for 4 strips, it's 8 kilobytes and it's 1/6 the memory, right? So if you go up to 10,000, that's why I kind of have ranges for it. So if you do 1, 2, and 3, you don't have to, you can put 0 in here for max count. Max count doesn't matter. Max count will only matter in the future if you have a 0 here, which is the default, right? Then you have to put the max count. The other ones in here, it will auto calculate it when a reload happens, which happens anyways with the display range because this right here is enabling sequential reload. So there's code in there already for sequential reload. So to put more code in there for a reload, it's not that hard to do. It's just more, I would have to I have to make the array already in there because when it's 30, I just make an array of 31. So it's 0 to 30. So then any value, I know how many LEDs to light up. But if I don't know the value, then that's why I'm having these ranges. So the value is going to be from 0 to 100 or 0 to 1,000 or 0 to 10,000 kind of thing. So this is in the future. So when I release Let Hook Strip, version 1.0, this will be in. I think it should be in pretty soon. It should be in version probably 5, maybe 4. So I just want to tell, I do have future plans for the display range to automatically do the max count. So I think there's enough calculations to do it. So since I have 2 processors and all that, and I don't think people will use it for 4 display ranges. And even if they do, it should be okay. Because we're talking about probably like 20 to 40 microseconds to calculate it, maybe. That's kind of like the best case kind of thing. So that's why I kind of wanted to put that in there. Then next thing I want to talk about is debug. So for any debug, oh, this kind of got like knocked off. There it goes. Okay, that's more centered. I'm like, what happened? So when you do any debugging, do not use scripts, AHKs, or launchers. So I tell this people all the time because you don't know if it's, your script is causing the problem or the HK or launcher. So when debugging things, do not use scripts, AHKs, or launchers. And even sometimes is the script, when you close things, it will close Hook of the Reaper before people can even read the error message, which you'll probably need. And also, it's just not me. I know other people like Argon from Demolished Shooters highly suggest this. That's why I'm like shouting it. When you're debugging, do not use scripts, HKs, or launchers, because I've been saying this from the beginning. And like I said, any debug, you don't want to have other things. You don't want to have things blocking. And this is probably easily the second biggest thing I had probably. Because the biggest one I always tell people is Demolished Shooter turn green, but no recoil, which I've gone over plenty of times. But the next one is probably second biggest one is probably people using scripts and AHKs and launchers and having something wrong in the script or AHK that's messing something up. But when you do it without the scripts, you can actually see the error data. Then people are like, oh, that's why it's erroring. That's why it's not working right away. But scripts, AHKs, launchers will hide tons of stuff. And also a lot of times, even when you're using launchers, it will make it full screen. So even if an error happens, you might not even see it. You can only hear it if you're listening to it. So definitely debug. This is probably the biggest thing is don't use scripts when doing it or launchers. Another thing is I put a ton of work in error messages and documentation. So if like lead hook strip controller is airing out, it will tell you pretty much exactly why it's airing out. If it's like a command with the number of if the number of arguments it's off, it will tell you, hey, the number of arguments are off. It's not lining up. You need to check that. Or if an argument is out of range, it will say, hey, this argument is out of range. So a lot of, that's why I said I put a ton of work into it because it checks everything. It checks to say, hey, do you have this color? If you're using a color that's not in your group file, it'll tell you. So that's why I say make sure you're looking at the error messages. And also, if you're playing games, use window mode for games. Because, full screens will block the error message. Like I said, with launchers and all that, it will always do full screen, and it will always block the error messages. So another thing, don't do cut and paste and pray. It works. It's kind of what I call it, because people will just cut and paste things and put it in and hope it works kind of thing. Kind of don't do that because, I've seen it won't work because I try to put a lot of things in to say, hey, this is not cut and paste safe. For that kind of make sure people don't just cut and paste things. So watch out for just cutting and pasting and praying it works, kind of what I have. Then also, please don't take this as, I'm being like, oh, I'm getting a hard on you. I mean, I'm definitely no saint and messed plenty of things up. So even for lead hook strip, some of the example files had a lot of mistakes in them from the beginning. So, and also I know that, I created it, so I fully understand it. So And if I find something wrong with working with a person, then if I update the documentation right after, don't take any offense to that, because I kind of do always do that, because if you're having a problem with it, I know like 20 other people are going to have the same problem. So I rather update the documentation so then people will know about it. So I know sometimes when people go, oh, this is it because of me, and I'm like, no, I'm just, if you're having this problem, a lot of other people have problems. So please don't take any offense if I update any documentation. And also a lot of things is like, also I can't do help people out all the time. As I say, I'm disabled, and also I suffer from chronic pain. So if I do kind of get short or kind of testy, it's more probably because I'm in pain or I'm tired. So don't take it personally. And usually if that happens, I usually take like 2 to 5 days off, because I don't want to be like, testy or mean to anybody. But if you're in horrible pain, it's kind of hard not to sometimes. And that's kind of like the issues with chronic pain people have a lot of times. A lot of times it's called the asshole tumor, where chronic people, they call it chronic pain people will get an asshole tumor, which means you're an asshole to everybody because you're in pain all the time. And I try not to do that, especially with my wife and my daughter. I do not do that, and my wife, and it says, she's very thankful for it, because she was really worried about that, because it does happen to a lot of people. So I just want to say that now, so just don't take any offense from it. So especially talking about debug, I know when you're debug, you just want it to work, you're frustrated, you don't know what's working, kind of thing. So that's why I just want to put that out there. Okay. Then the last thing is, I guess I know I'm probably the most the host. So if people do create game and default files for LightHook Strip or even for Ultimark, you can send them to me and I'll put them up on the website. So if people start doing game files, because I say for display range, you shouldn't do that with a default file. You should have game files for display range. And the reason for that is because not all the games have ammo value, and not all of the games have life value, because you can display life. So that's why I think it should go in the game files. And also later on, when I do advanced features, Hook of the Reaper will know if you have one light gun or two light guns. So if you have one light gun plugged in and you play House of the Dead, instead of having player 1 ammo and player 2 ammo, you can have player 1 ammo and player 1 life, right? So ammo will be on your left, life will be on your right. So since you only have one light gun plugged in, right? So if you have two light gun plugs in, then you can show ammo, player 1 ammo and player 2 ammo. So I kind of want to be ready for that too when it comes out. So that's going to be more player specific too. So if you do create files, just tell me, how many strips you have, kind of what stuff you're using for default, and the game files and that. And same with Ultimark. Ultimark is a little harder because the pin connections are really different, but since I'm using groups versus pin connections, it can work if you group them well, saying, hey, this is player 1's buttons and this is player 1's start button is group 1. So player 1 buttons is group 0, group 1 is the start, and so on. It can be doing, but then it also depends if it's RGB or regular lights. And like I said, I have the background, which is cousin of the display range, which should be in game file. So, but if somebody does want to want to host the files over me, please let me know and I'll let you do it. Or I know I'm the most reasonable person and I know that. So if people do start creating game files, please send them to me. Then I can put them up on the web page. Then people can grab them, and then hopefully we can have a lot of the game files done for LightHook Strip for 2 or 4 strips, right? So then people don't have to create them, they can just download them in. So right now I know there's not that much out there. It's pretty much what I created, and people are wanting to do it, and this is why I'm doing this whole tutorial, to help people write out these game files. So when you do the game files, please send them to me so I can put them on the web page, so then everybody can have them. But that's it. Hopefully, it's kind of a long tutorial going through everything, but hopefully now you have a lot better understanding about how everything works. Hopefully, and now you can feel confident writing out game and default files and group files. But that's it. Thanks. Bye.